All right. Good morning, Kyiv. I hope you are having a wonderful time at Devoxx. It was a very dramatic entry, I must say. So, my name is Nakul, and if you haven't figured out where I'm from, let me help you. I'm from India, and as you know, in my country, we have a tradition of stories, or shall I say a lot of stories. So let me share with you a story which my mother shared with me when I was a 6-year-old kid. And this story made a profound impact in my life. And, 20 odd years, it will come true in my life. It was a story about an elephant and a group of blind men. So there were a group of blind men who heard that there is a strange creature called an elephant which was brought in the kingdom. But unfortunately, none of them have, know what is the form and shape of an elephant looks like. Actually, they have never heard what an elephant is. So they say, well, we are curious enough to know about this strange creature. And they said, well, we will go to the king and ask him to show us the elephant. So they went to the king and say, oh, dear king, we would like to know, this strange creature called elephant. And the best way for us to conceptualize this is by touching. So the king said, all right, we can make the necessary arrangements. So one by one, the blind man started to touch an elephant. So the first person whose hand, landed on the middle part of an elephant, he said, well, an elephant is like a wall, a big wall. Another person said, nah, you are wrong. You are always wrong. I know what an elephant is. It's like a tree. And another person said, well, his hand landed on the trunk, and he said, well, an elephant is like a snake. So on and so forth, each and every one of them started giving their own interpretation of an elephant. And the last one said that an elephant is something which is smooth, hard, and it took me a while to realize in my professional career that I was the same blind man. Because the code which I was developing and calling the domain model was nothing but a soup, a technical soup, and a lousy one, not a nice one. So what I was developing were like classes with bunch of annotations and getters and setters. And those annotations will just help to save the object properly in the database. And that's what I was calling a domain model of. And I always say to my friend that code is like water and it reflects. And in my case, although I had the best intention to develop a really nice and functional software, however, it was reflecting, not the reality of the business. It was reflecting, some technical soup blurred with, lots of annotation in life. However, what was the reality of business was something else. So my perception was just totally blurred. But fortunately, I found this book, the blue book. Like, in Matrix, there were two pills, red and the blue one. So I took the blue book and I started reading it. And this book changed the way how I approach the software architecture. And it changed me fundamentally. So this book taught me that I should start focusing on the domains rather than on the technology. So domain should be the concept which I should care in the development cycle, not the technology. Technology is something which helps to achieve. And I read this book, and if I have to summarize what I learned from this book in 4 points, I would say that first thing which I started doing is I started placing the behavior in the domain model. The next thing I did is I tried to understand the reality of business, but not by my interpretation, but from the eyes of business. So we started working on developing a common vocabulary, which is called ubiquitous language. And that way we could understand what business meant and what we understood. I tried to create consistency across domain model thanks to aggregate. So I started using the concept of aggregate to provide consistency across the domain model so that when I have to delete something or add something, I can do it in a fixed manner. And finally, I needed to protect my domain model. So I started using bounded context. And the reason behind this was because in the same domain, we have a financial person who is asking that, well, a customer looks like this, and a marketing team which is saying, well, for them, a customer means something like that. And both of those definitions have to exist in the same code base without ifs and else and switch and hacks. So that's why with bounded context, I needed to protect them. I spoke about aggregates, so let me define it very quick in a single line for you what an aggregate is. So aggregate is basically, group of objects which naturally belong together. And they allow us to maintain variance in the code base. So if you want to delete something, if you want to, delete item, and you want to delete all the items from the order, you can do it thanks to aggregate. So they are basically a group of entities that naturally belong together. And this is all about DDD, what I wanted to speak. The next part, which I want to touch upon, is an architecture pattern in which events are considered as the source of truth, and based on which components can create their state. At least that is what most of the people thinks like. Remember the blind man story. Actually, event sourcing is not only about publishing events and consuming it. There is one very important detail here. The component which is publishing the event is the same component that end up consuming those events. So basically, there is no other state in the system except the events, and they are stored in the event store. So let me give you an idea, how event sourcing look like. So let's say we have a traditional application, and we wanted to buy some food online. So let's say we place an order to buy a burger, and at the end of the day, we have something like this which end up in our database. I think most of you are aware of that. So we can have some, primary key, we can have some, quantity, we can have the item which we want and status. Maybe we can have a bunch of more attributes, but something like this ends up. Now let's try to see the same event from the eyes of event sourcing. What does it look like if we design the same app using this architecture? So first thing what we did is, well, a user added an item, veggie burger. Then the person also added a salad. Then the person added an ice cream. Why is that? Don't ask me. But then something interesting happened. The person removed the ice cream. The person then removed the salad. Finally, the order was confirmed. It was shipped. So as you can see that at a blink of an eye, a whole series of events took place. And this provides a very useful information, especially to the business people. Maybe the reason why the person started removing the item at the first place was because the shipping time was too long. Or maybe the shipping cost was too long, And if we can provide all this information to the people who know the business best, they can advise what sort of machine learning and stuff we can do to help our customer to use our services to the best possible extent. So in reality, all of this, what you see, is the food for big data and machine learning. We can just feed this and help to create a better user experience. And there are companies like, for example, Amazon, which have done a significant work using such information. So for example, Amazon is so good in predicting the user behavior that they will ship a product before even you buy it. And they don't do it only for a group of people. They can do it at a user level, specific level. So imagine, just let it sink that someone is shipping you a product before even you bought it. And at the end of the day, Amazon is still online, so they are making money out of it. So a natural question that pops up, after hearing event sourcing is where do all these events live, We live in our home, so where those events go and live? Well, the answer is event store. So what is an event store? Well, an event store is a storage which basically helps to save the events which are published and consume those events. and make these events available for the consumers. So there are 3 things which you should know about event store in terms of semantics. And the first is that an event store should allow very fast append operation. So you want to add events. So if these are events, you want them to happen as fast as possible. The second is, since aggregate are the ones which produce those events, and you don't run application in one box, you run on plenty of other boxes. That's why tools like Kubernetes and other things exist. So you want the event store to validate the sequence number, yeah, as well. And the final thing is, it should also be able to provide very fast access when someone wants to read the information. Because you don't want, reading all the history going to take, 1 month. The developers are going to go on holidays. So you want the read to be as fast as possible. And there are a bunch of implementations from Event Store, like Greg Young has one, which is called Event Store. There is also one by Axon IQ, which is launched in 2018, which is called Axon DB. You can also use relational databases, but if you want to do event sourcing at a large scale, and by large scale, I mean billions of events, I will suggest don't go for this option from personal experience. It's painful. It's painful stuff here. Or you can roll out your own implementation. One of the final things which I want to touch before we dive in the demo and see how all these things looks like is CQRS. So one of the problem in life is the domains tend to be too complex, and they tend to evolve. So what we need is, we need different domain model in order to target those problems, even within within the same bounded context. So we need different domain models. And one common way to do is using CQRS, in which you can divide the system in 2 parts, the command and the query. In command part, you want to nail the domain logic. You want to just nail it there. And on the query part, you want to nail the domain data. So what are commands? Command is, I want to send an email. I want to buy an iPod. Why? Because yesterday was a Black Friday. So when you want to do something, so you want every command have a side effect in a system. Those are the commands. Query, on the other hand side, are desire of information. I want to know the top trending products right now. I want to know the financial report from last 1 year. So query is about the desire of information. So let's take a look from the user perspective how this architecture looks like. So we have a user here. And the commands are routed to the command model. And you want at this part of your system, the people who have the most intimate knowledge about the domain to work here, so they can get the domain model right. The queries are routed at the other part of the system where the projections live. And you can afford here to have the people who don't have so intimate knowledge about the domain, but they still can contribute to the project here. And obviously, how the talking between command model and projections take place? Obviously, with events. So the command model can publish some events, and projections can handle those events. However, rather than publishing those events and forgetting about them, we can do something more. What we can do is we can start storing those events. And by this way, what happens is, for command model, the event becomes the only source of truth. I hope it rings a bell in your head, because this is event sourcing, which we just discussed on previous slide. So we can use CQRS and event sourcing all together. It all sounds so easy. However, I like to say, the devil is in the details, or shall I say the technical details. So when you want to implement something, want to make money out of this, then you say, oh, I forgot about that, and I forgot about this. And all those strange creatures starts to roll in. So let's take a look what I mean by the technical details. So if you want to implement CQRS, what you need to make sure that your commands are routed properly. You also want to make sure that your events are delivered in order. So you don't want, for example, player to withdraw the money before the player is registered. I mean, good for the player, but bad for the business. So the order of the events really make very important part in this architecture. Also, you want to make sure, if, for example, you have roll out, let's say, your own knife implementation of CQRS, and you have multiple components which want to consume from the same source, you may end up, using twice as much as CPU or buffering too much because you are deserializing and serializing things in an unoptimized way. You also have to think about race conditions. And I'm not going to touch about asynchronous and synchronous model here. So all these things you have to think about when you want to implement CQRS, And now you start to think, well, you have two things to do. One is like you can start creating all that source code, and there is nothing wrong with this thing. But now you are not contributing anything towards the business. What you are doing is a technical solution here. Or maybe you can start to use, to get started, with a framework that provides you a bare minimum functionality. I hate to name drop the frameworks in the conferences, but in our case, we use Axon at production for 6+ years, and we had like more than 30 billion events in our event store. So, and we are still making money out of it. Not from the framework, but from the production system. So Axon started, I guess, somewhere in 2009. And from that time, the framework is constantly being developed. And as of 2018, the company finally, launched their own event store and Axon Hub. They also recently open source all this under Axon server. So everything is open source. And if you want to, I don't know, go beyond certain threshold and use some enterprise services of monitoring, then you have to pay. And Axon, if I have to say, in one word, is nothing but location transparency and some other stuff. So by what I mean by location transparency is, let's say you have component A and component B. And component A wants to talk to component B, but it don't want to know where the component B lives. And that is location transparency. And we can use, for example, APIs with futures, or we can use messaging pattern to implement that. And why location transparency is so important? Because let's say you are starting to build your application, and you can start with a monolithic. And let's say you have done your DDD right. And now what you can do as the time progresses and you have to scale out, you can start extracting those bits in microservices, because I never made an assumption that this thing and this thing sit at the same address. So that's the power of location transparency here. So when you don't assume where the components sit together, their location, life becomes simpler. So now is the best part of the application, where we will see the demo. So let me show you the demo. Okay, so before I will dive into the source code, and we will take a look on the bits and pieces which make this application work, I would like to tell you a small information what this demo is. So I created a simple application here where a person can place a bet. And in order to place a bet, first you need a wallet. So you need some virtual digital wallet. So we can create a wallet. And at the end of the day, you win some money or lose some money. And it should not be any surprise that I work for an online gambling company, so I chose this sort of an application. So let me create a wallet for me or for Devoxx. And what's the currency in Ukraine? What's the symbol of currency? UAH. Okay, so cool. So what I want to do right now is, when I want to hit submit, I want to execute a command which should create a wallet for me, and it should also publish some events and maybe some other display logic will want to gather that event and render some information. So when I click submit, I get an error message. Okay, so it means, this currency is not supported here. So we have to go with euros. But at least it shows that you can do the validations. So now I'm going to again click submit, and let's hope a command is going to execute it. And the command is executed here. So what happened here is a wallet get created in the background. And now I can start loading some money here. So again, let's say I want to put some money in my wallet. And when I want to click submit, I want to publish a command to load some money in my wallet. And then I also want to update some information in the UI. And let's see whether it works. So I click submit. A command got executed. Event got filed. And we will see in code how all this is happening. There is no magic in computers. And this projection get updated. And you don't have like restriction to have one projection. You can have multiple projections. So what I mean by that is, let's say, for example, here and here. Let's try to squeeze it in. Sorry, my CSS skills are not the best here. But that's OK. I hope it's manageable. So what I mean is, look, we have here one read model, the second read model. We call them projections, basically. So we can have n number of them. And whenever someone load a money, we want to update all of them. So here, what I'm going to do is I can put like 50 grand. And I click submit. So as you can see, this is updated. This is updated. And the important thing to know is, like, all of this is rendered in a same page. But they are not one application. They are different components, which are just listening to the events. So although it's happening fast for the eyes, it's not like they are all just a one application. All right, so I have some money. So what I can start doing, I can start spinning something. Yeah, that's what you do. When you have money, you start to spend on stupid things. So I can make a bet on Foo, and I can put 25 grand. And now this is important to know. So when I'm putting some money to bet, what should happen from the business perspective is that that much money which I'm betting should be frozen. So it should not be accessible, because we don't know whether the player is going to lose this money or win this money. And depending on the outcome, this money should disappear from the wallet or multiply in the wallet. So I click submit. And as you can see, my funds get frozen. And the balance got updated, which was 100K, but now it becomes 75K, and I lost the bet. Let me show you again. Let's make a bet on bar. So as you can see, I have here some money frozen, and this also shows on the UI. And as this projection show, I again lost. So let's try on something else. Let's try Baz. No, or Chuck Norris. He never fails. So look, 25 grand. So again, I'm putting some money, and depending on the outcome, it will take some time, and we win some money. You see, that's how you always are guaranteed your demo never fails. That's the keyword. So that's how our demo looks like. And as you can see, all these things are getting updated here. So let me show you the code now, real fast. Sorry, here. So first thing which we spoke about is commands. So let's take a look on API and on wallet. So what are the commands? Can you read it? Yeah, awesome. So commands are nothing but a plain Pojo object. So in my case, I'm using Kotlin. Why? Because I just think it is concise and it fits on one line, so I don't have to scroll up and down more for you. But you can use Java if you wish. Here, there is nothing which is dependent with Kotlin. It is a simple plain Pojo which have some fields here, wallet ID and currency, and a magic annotation. And what this magic annotation does? Well, remember that a command, when it is executed, it needs to know an aggregate. So if I am a command and I want to send an email, I want to know the component which is handling the email processing, right? And how do you make this connection? You use @target identifier. You say, thanks to this annotation, Axon is going to take care to make this magic connection for you, for which otherwise you have to write some code. And you can create other commands as well. So I have deposit command, request withdraw, approve withdraw, and so on. So we spoke about aggregate, how the aggregates looks like. So as you can see, that first thing I have here is I have an annotation called @aggregate here. And this is picked by Axon, and also Axon provides support for Spring. So if you love Spring, you can keep on using your Spring stuff with Axon. And the next thing which we need is what we have in aggregate is some bunch of fields. And this field is important. You remember @aggregate identifier. So let's go back here. So let's say I will call this foo here, this field, then here I have to call it also foo. Okay? Because this is the name have to match, yeah? I mean, you have to help the frameworks at the end. And then there are a bunch of other fields like currency, available. And the important thing to know is these fields are not here because we want to save them in databases. These fields are here because it makes sense from the point of view of business. What I mean is, let's say if the business say, hey, we don't have any restrictions on currencies, yeah? And you don't need to do any validation about that. Well, I don't need this field, and I can get rid of this code easily. So each and every field in the class makes sense because it represents something meaningful for the business, not something meaningful for your Hibernate or other things. So you are not just vomiting the code here one by one by one. And after that, there is this constructor, and I will come back to this, why we need that. And then I can start processing some commands. So this is the reason why we got the error message there. And after that, I can do some validation. Here I'm throwing illegal argument exception. Why? Because it's a demo, but in real life, you should throw something more meaningful like business exceptions. And once everything is validated in the command, you can apply the events. In normal Java application, we do something like this. We will do wallet ID is equal to command dot this dot command dot something command dot this dot. So in a normal Java application, this is everything. This is how we were grown up. We were raised by this sort of code. In constructor, you initialize the fields and you make the changes. But not with event sourcing. Why? Because in event sourcing, remember the events are the source of truth. So all the state change happen in an event sourcing handler. So in my case, there will be something which is listening for an event called on wallet created event. And let me show you. Here I'm applying the wallet created event. And what is wallet created event? Well, as you can see, it's a simple POJO, which has some meaningful information like wallet ID and currency. And the name is in past, wallet created. That's the convention which you want to follow. An event is an immutable thing. And on top of it, an event should be named in past because this is something happened. You can't change that information. So this is a convention which you follow. So here we are applying the event. Some component can listen for this event, wallet created event. And here I can initialize my fields. So that's what I do. And it's annotated with @EventSourcing handler. And this is important that the parameters match the type of the event. And in the similar way, when I was depositing the money, I was doing some validation and again firing some event. And as you can guess that I had some deposited event. And when the deposit was made, I was just updating the balance. So as you can see, it's very simple application. There is nothing fancy happening here from domain point of view. But still, there is a lot of things happening behind the scenes. So we have commands and events getting published. And the final thing I would like to show you is how all those projections and display looks like. So if you want to create a projection, there is no magic annotation for projection. You don't have like a class which you annotate with projection. What you do is you just create a simple class. Again, you can use Java if you want to, or Kotlin. And you just annotate your method with @EventHandler and say what type of event it is interested to listen in. So in this case, I was interested to listen wallet created event. And when this event came, I'm just storing it in entity manager.persist. Why is that? Because all of us are aware of relational database. So I'm using for demo H2 database in memory, but you can use Cassandra, Mongo, Neo4j, sky's limit, go crazy in this part. And then what I can do is I can emit some new events for my read model. So for example, here I'm emitting wallet summary update. And if you are interested how this event is captured, just clone the source code from GitHub and you can take a look. But I hope you get the idea how all these things are working together. All right, so let me, let's go, not this thing. So let's play this. So this was the demo application, and again the source is published, so you can take a look. But there is something beyond demos. This was a hello world, but in real world we don't have hello worlds. We need to make money, and what happens is you have third-party components to talk to. So for example, in our domain, in gambling industry, what happens is when you are making a withdrawal, you need to know your player. So there is like KYC, know your customer service, which can tell, hey, this customer is genuine or not. So basically, you have a third-party service to which you should call, and this third-party service do some processing, and then it returns you, well, it's good or it's bad. However, this service don't have to return immediately. It can return up to 72 hours. It can take 72 hours. So how do you make sure, about the complex transaction management in such a system? So how do you make sure that, if this service returns OK, you allow for withdrawal, and if it doesn't, return OK, then you undo all the things? Can we use ACID, in life? I'm afraid ACID is not the best fit for this architecture. Why is that? Because these transactions are long-running transactions. And if you try to do an ACID transaction, which is long-running, it is going to make your DBA so angry that he's going to chase you down to kill you, basically. And your database is going to cry like a baby, like, have some mercy on me. So you don't use ACID in this world, Like the name say, ACID is not good, for the life in event sourcing. So what we can do, we say, eventually everything will be good. Eventually the world will be a happier place. And it focuses on basically availability. So it's basic availability, soft state, eventual consistency. And let me show you a demo of this, what I mean. So here again, we are back in our UI. So here we have a request withdrawal. Can you all see this, the down one box? So what I'm doing here is I'm saying, well, I want to withdraw 2,000 from my wallet. I submit a command. It calls a third-party API. Obviously, I mock it for the demo. And basing on that, the withdrawal is approved. But sometimes it should be, like if I try to withdraw 6,000, for example, it's a big chunk of money. And maybe the service say, well, I'm detecting that it is a fraud because of some IP address or something, and you shouldn't, provide. And this is implemented by a concept which I describe. So how do you do all that stuff? Well, you can use Sagas for them. So first I will show you in code how the Sagas look like, and then I will tell you what they are. So here, first thing you need is another annotation. I mean, you can do this by your own again, yeah? So don't get in love with a framework, yeah? Keep your emotions for your family, not for the framework. Otherwise, the worst thing happens in your life. So here what I'm saying is grasp the concept. So the concept is Saga. So you have a Saga, and a Saga need to be started. And in my case, the Saga is started when someone make a withdrawal request. So when I want to withdraw, the Saga is started. And it can end in two places. In first is a OK path, in which I get the thumbs up. So I say, OK, thumbs up, everything is OK. And then I say, OK, approve the withdraw. Or it can say, nah, it's not OK. And in that case, I inform the rest of the system in my end by firing another command, which is called deny, like don't let the withdraw happen. And the components can react. So, OK. Yeah, now the resolution is better. So what are Sagas? Well, basically, Saga implements the base transaction. They react on events. And they can coordinate between different bounded contexts. So you can have a payment and email and all those different bounded contexts which can talk together thanks to Saga. So that's what Saga do. And not only that, you can coordinate between various different aggregates as well. And what these Sagas look like, you know, what is this magic here? So Saga is nothing but a simple event handler, you know, an event handler that can maintain state. That's what Saga is. It's a long-running event handler under the hood. And that's all about Sagas, nothing more I'm going to tell you for now. And since it is 2018 and most of the business have the requirements to scale, you know, because to support various different locations, very different geographic, various different countries and so on. So I took a time to, scale this demo. I'm going to just mirror my display forever now, so just bear with this display. And here is the same application. So if you want, wait a minute, do I have the internet here? Okay, that is not something which I plan here. It seems we are having some internet problems here. Let me try to. Devoxx speakers, okay. This is teasing me. Okay, it works, it works. No, it's okay. It was just teasing me to click on Wi-Fi icon. So here, if you folks want to interact with this application, go to this IP and you can play with this application. So it's deployed on Kubernetes, and if you get in player UI some error, just try with a different username, because someone might have used that username. So you can play with this demo, and it's running on Kubernetes. And here I have the same thing. So here I have, for example, a wallet, and I can create here for DevoxxUA Ukraine. And this time we know that the euros are the correct one, and I can submit, and I can then load some money, here, submit and make some bet here, basically. So I don't know, bet on foo and 25,000. And this is all running on the cloud, the same application which I show you. And it seems foo lost. So here is how the services look like. I think now it's readable. So we have a bunch of services here running on a pod on Kubernetes. And why Kubernetes? Why not Amazon? Because simply it was cheaper for the demo for me to get started. So I didn't want it to pay for Amazon. I just choose the cheapest cloud provider. That's me getting cheap. It have nothing to do with affinity to one cloud or the other. You can run it on anywhere. The interesting thing is, I have here a query. So this is my event store. I can see all the events which happen in my event store here. And what I can do is, for example, if I'm interested to know about something specific, let's say about DevoxxUA, if I remember. Oh, you can see I have here all the events numbers. So the first event which happened in the system was that a wallet was created. Then the wallet had some deposit. And what was the deposit payload? Well, this much amount and this much, that was the currency. Then someone made a bet. This is the amount which the person betted. And this was the currency. And then finally, someone placed a bet, foo. So as you can see, this is all the events. And that's how they get persisted in the event store. And they are all ordered here in the right order. And I can look through all the events in the system. And I can query it by anything what I want here. And someone created my wallet and Chuck Norris. OK. And a Vova, and say, nice. So since you folks are interacting with it, what I can do is, that's a good sign of an application, I can scale any service. So for example, I see a lot of you, creating the wallet, and maybe my wallet service can't handle the load because only 2 instances are running. What if I want to scale that part only? Well, guess what? If the internet is going to help me here, I can say, well, I want to scale my instances up to, I don't know, these many number. I can do here whatever I want, yeah? So now what I want to do is I issue to Kubernetes a command that please scale my only this service, which is called wallet instance. And hopefully, it will take a bit of time, reach there, and then I can have this number changing. So I can scale an individual service. And as you can see, they scale from 2 to 5 here. So I can scale this thing. Moreover, one interesting thing I can do here is also with commands. So as you can see, I have deployed this on a cloud in a region and on various availability zone. And I can take a look here on which machine the command is getting processed. So here I can see, for example, this box have processed these 2 commands right now, and this box have processed these 2 commands here. And this one have processed, for example, 7, this is 12, this is 21. So as you can see, I can see those matrices, like which boxes are processing those commands. And also, when it comes to the read part of the system, so I can also see like how much writes are going by using the command side. But if I have to know like what is the ratio of my read, I can look here. So I can see, what type of queries were made in the system and how many of them are made. So here, right now, only 2 queries are made for this specific wallet summary query. And all this information comes handy when you are going live in production. And the final thing which I wanted to say, like how Axon supports Spring in the demo part, is you have something called Axon configuration. So you have Axon auto configuration. Okay, it's downloading. So as you can see, if you are using Spring in your in your project, you can just drop the jar and the auto configuration kicks in. So basically the command bus and the event bus and all those buses just get plumbed together. And I don't want to scare you with the names event bus. It's not enterprise event bus or something like that. It's just an abstraction. I could have called it foo bus if I wanted. Event bus is basically a concept, and you can provide any implementation. So what I did is I added in the framework support for Kafka because it makes a bit life easier to, let's say, have a very high throughput event bus, and you can just drop in the jar and it will just auto-configure Kafka with some sensible defaults. And you have also AMQP and Rabbit and all that stuff. So you can just choose your flavor and the bits. Okay, so sorry for all this switching, but the resolution is a bit not ideal right now. So that is all the demo which I show you. But now, if you folks go home and you want to play with this stuff, then a big question comes like, how can you find, commands, aggregates, bounded context, domain event, projections, policy, and all those things, I'm afraid Google cannot help you in 2018 about this. You can make as many queries to Google as you want, but Google is not going to help you in that. So then you will say, well, we know Stack Overflow. Go and make a Stack Overflow question. I'm afraid Stack Overflow is not going to also answer you anything about your domain. So you are left at your own. So that's why I wanted to share how when we build a system in production, what are the things which help us to find the commands and aggregates and bounded context. And we use something called event storming. And event storming is not brainstorming. In brainstorming, you come up with the ideas and you just talk together and generate ideas. Event storming is more about going deep in your domain and sharing the common knowledge with the business folks to get the bigger picture of the domain, what you will be developing for. So this is domain-centric event storming. And how the event storming looks like at 10,000 feet. Well, first thing we do is we create some chart like this, We created it once and we reuse it, so you don't throw this piece of paper. And here it says like what those stickies means. So which color of the sticky to pick. So we put some stickies and we let the people from the business and the technical people sit together and they start writing the things which matter. So what happens is they started placing the things on the wall from left to right. So the time goes like this, yeah? And then the discussion evolves, and we say, well, this thing makes sense, this doesn't make sense, and blah, blah, blah. And then this happens, and this is the picture which I like the most in the full presentation, because this is my time which was going to be wasted developing something which will be rubbish. And that is something which you can detect thanks to event storming. At a very early stage. And why? Because business are the people who know how to run the things. Let them do their job. They know, don't create very fancy solution. What happens if, the person delivering the milk bottle, if the bottle breaks, what we do? Shall we retry? Shall we do a transaction? No, business say, well, it doesn't matter. We will just write them an apology letter. And you are like, what? Yeah, that's what happened. Business have very, very different way to handle the things. And don't over-engineer the thing. I mean, spend the time in the right place. And finally, when you have, the discussion evolve and, some time pass by, your bounded context. So here it might not be visible, but there is a pink line here. And your bounded context starts to fall naturally and organically. So you don't have to think like, oh, what will be my bounded context? Is it going to be shipping? Is it going to be, order? No, though they will start to fall here. Your domain models and your bounded context will start to fall. And not only that, you will know about the commands and events. So what is the final output which you get by doing event storming? You get a wall filled with lots and lots and lots of stickies. But those stickies contain some really valuable information. So they can help you, like you knows what are the commands in the system. So what are the actions which are going to be performed against your system. You know about your aggregates. You know about the external system. This is super, super important because many times this information takes a while to propagate between developers. You know about your domain event. You don't have to assume that shall I create an event bet placed? Shall I create an event order deliver? You don't have to guess it. Just talk to business. Business are going to tell you. And you know about your domain events. You know the read models. You know the policies. So you know what sort of validations business really care for. And at the end of the day is basically, all that stickies become the input for the engineering. So let's try to recap. You know, DDD domain. DDD says like we should focus on domain first and technology later. And DDD is not about perfection. In reality, writing code is not about perfection. It's not like first time you write a code and it have to be perfect. I mean, if you are Chuck Norris, yes, you can hijack even a demo. That happens. But in real life, we don't have the superpowers like that. Even in open source project, people commit and then they improve. So making mistakes is something which, you know, which should be kept in mind. But that they might happen, but we should be able to improve. These mistakes should not become a standing stone in our life, you know. CQRS and event sourcing's love, you know, goes hand in hand. Axon helps to put theory into practice. And we can do collective learning by doing event storming. So we can let the people from business and developers learn together. And at the end of the day, it's all about learning in life. You know, the more you learn, the better you can connect the dots in life. So thank you for your time. And we can have a Q&A. And there are two important things. Oh, sorry. Here you go. Yes? Okay. And, okay, just a quick thing. Please rate if you like the talk. You know, voting is important. America have shown us. If the voting goes wrong, what can happen in life? Back to this. And let me take a photo. This is the important part for the Twitter. So, you know, we have to do that stuff. So please don't leave the room yet. So let's say cheese or something, or open source. Okay, thanks.
Okay. So for example, we have a Saga that says we withdraw some money from the user. We check if it's possible to send that money to another user. And if it's possible, we send it. So we've got an event that user wants to send. We do the checks. We generate another event. What happens if, for example, at that point, when the money was already withdrawn, we started performing the check. It takes some time. And at that moment, the server went down. So is there some mechanism to persist that Saga and then replay it?
All right. So let me see if I get the question right. So basically, you are doing a financial transaction and something wrong happened. So there are two things which you can do. First is obviously Sagas, since they are long running, they are persisted in a database by default. And the second thing is you can also, depending on, again, on your context in which you are working, you can also roll back the things. And how you roll back in Saga, and it's a really important question which you ask, is you can fire the events which will roll back. So for example, if you have added $50, you can deduct $50. I'm not saying this is what you should do, but there are two ways. So Saga, yes, it is persisted in the database. That answers your questions. But in the second part which I wanted to touch upon is that in Saga, if you have to do rollback, you can't just roll back just going to a database and do something. You will cry at 2 in the night, why the hell I did that? What you do is you say, well, I'm going to publish some events which will revert the things. In the correct order. So you go to the business and you say, okay, this thing happened, what we do? And they say, all right, send, I don't know, a free headphone. So Amazon does like this. You run out of the shipping and they say, all right, we are sorry we couldn't do that order processing, but we can, as an apology, we can send you a nice, headset. And you are happy that, okay, that happened because I get a free headset. Yeah, so business do like that.
Hi, thank you for the talk. It's very good. You mentioned at the beginning that you think relational databases, you think have problematic for this area. I wanted to know specifically from your experience, how did you see that didn't suit this paradigm?
Sure. So why I said relational databases are not a good fit? Because I don't like them. No, that's not the thing. And now you will go on Twitter and start tweeting. No, 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 no. The thing is, relational databases are good to store some type of data, but in event sourcing, if you take a look at the semantics of the data, what you have is you just append. You never change the records. Once it's written, you don't change. You don't go and say update star, 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 star. Only you need is append, 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 append. And then what happens is also you don't need indexes there. And we try, for example, back in the days when we started building the system, we didn't have a lot of tools out there. So we had to build our own event store, and we use relational database because that's what existed back in the days. We didn't have NoSQL. But when the volume of the event reached to, let's say, a scale which was quite big, we have like billions of events, like 30 billion plus. Relational database maintenance of this became really, really, really painful. And also we started realizing that replay times with relational database was taking way too longer. So basically writing fast, reading fast was not the case here, because we had to pay the price also for maintaining some indexes and whatnot. And what we did in our life is we hire a wizard, a DBA, who take care of all that stuff. But still, it's in terms of maintenance, is not the best thing. And also, if you do the aggregate validation, there, yes, you can do a primary key constraint or something like that. But at scale, again, it doesn't work well. So that's why I said that if it's possible, use the right amount of right database. And also, when you are storing events in the database, you have to be, like in our case, so one thing which we thought is go with the default, and back in the days, XML was a default. And now all of a sudden, when you have, the events started to generate, all that, repeated XML starts to take more and more and more chunk of information then. And I mean, in a nutshell, relational databases are good, but we didn't need ACID here, and we needed something which can provide like super fast speed, because it's not enough to have those events. It's very important to have access to them. It's like food in the home. It's not enough you have the food, but it should be ready in the table when you are hungry. That's what happens with the relational database. The big data team wanted to process the data, wanted to chunk some number, and now relational database is taking ages to give back the answer.
So you can have maybe a mixed solution.
Obviously. But that happens as, for event store, you need something which can persist the event. But yeah, we have the mixed solutions, and we are migrating in the process. Thank you for the question.
Okay. Hi, thanks for the talk.
Where are you? Oh, there.
So what is the aggregate lifecycle? You send a command, then the aggregate will be recreated from snapshot and events.
Oh, yes.
And then what?
Okay.
After processing the command, will it stay in the memory and wait for another command or it will just die?
Cool. Very good question. I apologize. I forgot to show you what happened in that constructor. So that was the answer. So what happens is, first time when you are accessing an aggregate, it does not exist in the memory. So what is going to happen? It will go at the disk, the framework, it will load the aggregate, and by loading the aggregate, it will create an instance of aggregate and start replaying all the events. And now, if you have, like us, billions of events, and you start to replay, it's going to take ages. So what is the solution? You do snapshotting. And once you have aggregate loaded, it stays in the memory.
Okay, next question. How do you deal with the problem that you can have an aggregate only on a single host in case of scaling? So you cannot have the same aggregate loaded in different hosts, because this way you will lose consistency.
So in this case, what you can do is, so when you are saying about aggregate, you need to think about two things here. First is you need to make sure that this particular aggregate is the one which is going to process all the events for that particular user. Otherwise, you are going to mix it. And how do you do it is you use command bus, a scalable distributed command bus, and it uses consistent hashing under the hood. So thanks to consistent hashing, you make sure that, for example, for Bob, this is the aggregate. This box is going to manage the event. And for, I don't know, Baz, this other node is going to say. And if this node blow up, for example, for bar, you know, the other node is going to overtake. But that routing is happening thanks to command bus, and consistent hashing is the key. So you always want to make sure that if my event goes to you, then the second events also will be handled by you. Otherwise, you will have you can have some sort of strange behaviors happening in the system.
What in case of restarts?
So in restart, it happens. Like restart, you should embrace it. The failures happen, and what we do in that case is you can recreate, because all the events are stored in the event store.
The problem with the consistency in case of restart, because you have consistent hashing, and I think it's.
So in that case, you mean so let me understand whether I got the question right. By restart, you mean the restart for the box on which aggregate was running?
Yeah, the whole crash of the box, let's say.
Okay. So in that case, if you have consistent hashing in place and things are running on the box, another box is going to overtake. What is going to happen is another box will receive a command, and it will say, oh, I don't have this aggregate. What it is going to do, it will go again, it will load again, replay again, and you will have. Basically, the load time will be maybe a few milliseconds longer.
One more question for me. Thanks for the speech. Yeah, I'm here. So I was curious, have you ever faced with any questions related to GDPR and event sourcing? I mean that there is some data protection and we only write there, but the user has a right to insist on removing his data from where we store it.
I mean, I'm from Europe. So originally from India, but lives in Europe. And yes, GDPR is something which knocks on our dream. So the first time when I heard about GDPR, I said, well, here is an architecture which says, like, learn everything about the user, and now we have to delete. And if we start deleting, it doesn't make sense. So what we do to handle the GDPR is basically you can encrypt the data with a user key. And when the user say, well, I want you to forget, you basically delete the key. So the user have the key with which it can decrypt. So you just delete the key. So all the data ended up being encrypted, and that is garbage for us because we can't decrypt and use that data. And there is also a module. I think Axon have worked on that to provide a module if you need. But basically, if you want to build your own framework, what you need to do is encrypt the things using the user key, and when the user say, well, forget about it, just delete the key, not the events. And then it will be a garbage for you.
Okay, thanks.
All right.